This may be the biggest transformation ever attempted inside a Tesla factory. It starts deep inside Giga, Texas. Elon Musk is preparing to tear out a massive portion of what traditional car manufacturing looks like. Entire forests of robotic arms, miles of conveyors, and countless individual parts are on the chopping block. In their place, Tesla is betting on something so extreme that it has the entire global auto industry watching closely. The company has revealed plans for a Giga Press upgrade so large and so powerful that it pushes the boundaries of mechanical engineering itself. This is not just a slightly bigger casting machine, it is a fundamental rethinking of how a car is. Built from the ground up, and it could permanently change the economics of making vehicles. To understand why this matters, you have to understand how cars are traditionally built. For over a century, vehicle manufacturing has relied on assembling hundreds, sometimes thousands, of stamped steel components. Each of those parts must be formed, transported, positioned, welded, inspected, and aligned with extreme precision. Entire factory floors are dedicated to this process, filled with robotic welding arms working non-stop. Every additional part adds cost, time, weight, and complexity. Tesla's vision flips this logic on its head. Instead of assembling hundreds of pieces, the idea is to cast huge sections of the vehicle, or even the entire chassis. As a single solid piece of aluminum, produced in one shot, this is where the Super Giga Press comes in. Imagine molten aluminum, injected into a mold the way plastic is injected to make a toy. Now scale that concept up to the size of an entire vehicle structure. That is essentially what Tesla is aiming to do. While competitors are proud of machines in the 16,000 tune range, Tesla is pushing toward an almost unbelievable 50,000 tons of clamping force. The number itself sounds abstract, but its implications are very real. That level of force allows for enormous molds, huge volumes of molten metal, and castings that are far thicker and more structurally complex than anything that has come before. The global race to build larger casting machines has been accelerating rapidly. Tesla shocked the industry when it introduced a 6,000 tune press for the Model Y. That alone was enough to collapse dozens of parts into single front and rear underbody castings. China responded quickly, rolling out 7,000 tune systems of its own. Tesla then escalated again, deploying a 9,000 tune press for the Cybertruck, pushing the limits of aluminum casting even further. Chinese automaker Xpeng answered with a 16,000-ton hypercasting machine, currently the largest publicly known system in operation. For a moment, it seemed like China had seized the lead. But Elon Musk does not compete incrementally. Instead of matching 16,000 tons, or even slightly surpassing it, Tesla appears ready to leap straight to 50,000 tons. That is not a small step forward. It is a massive jump that changes what is physically possible inside a factory. To be clear, the 50,000-ton figure does not refer to the weight of the machine. It refers to the clamping force, the force used to hold the mold shut while molten aluminum is injected at high pressure. In engineering terms, that translates to roughly 500,000 kilonewtons of force, more than 3 times what even the largest Chinese systems can currently deliver. This level of force opens up entirely new possibilities. With smaller presses, manufacturers can cast individual sections of a vehicle, such as a front or rear underbody. With enough force, however, Tesla can use much larger molds that combine multiple sections into one casting. In the most extreme case, this could mean casting the entire unibody structure of a vehicle in a single shot. That is a radical departure from traditional manufacturing, and even from Tesla's own current approach. One of the most important advantages of this system is speed. Casting is fast. Once the mold is closed and the metal is injected, the process takes seconds, not minutes. If Tesla's claims hold true, a vehicle structure could be produced in under 5 seconds. That does not mean a fully assembled car rolls out every 5 seconds, but it does mean the most complex and time-consuming part of the build process becomes incredibly fast. When you eliminate thousands of welding steps and hundreds of robots, production lines become shorter, simpler, and far more efficient. Another major benefit is factory footprint. Traditional body shops take up enormous amounts of space. By replacing long lines of stamping presses and welding robots with a small number of massive casting machines, Tesla can dramatically shrink the amount of factory floor space needed per vehicle. That means lower construction costs for new factories, faster ramp-ups, and the ability to scale production much more quickly than legacy automakers. Weight reduction is another key factor. Every weld, bracket, and overlapping joint adds mass. A single large casting can be optimized for strength and rigidity while using less material overall. Thicker sections can be placed only where needed, and unnecessary reinforcements can be eliminated. The result is a lighter vehicle with improved structural integrity, which directly benefits efficiency, range, and performance. Cost savings may be the most important outcome of all. Each robot removed from the line saves not only the cost of the robot itself, but also maintenance, programming, energy consumption, and floor space. Fewer parts mean fewer suppliers, less logistics complexity, and lower inventory costs. Of these savings compound over millions of vehicles, the reduction in cost per car can be enormous. This is why many believe this technology is a critical piece of Tesla's plan to deliver truly affordable electric vehicles to the mass market. Chinese manufacturers like XPeng have already demonstrated the power of large-scale casting. Their 16,000-ton machine can produce massive underbody components, collapsing thousands of individual parts into just 2 large castings. This has allowed them to reduce production time and costs significantly. But Tesla's proposed 50,000-ton system goes far beyond this. Instead of casting one section per cycle, Tesla's machine is designed to cast multiple vehicle chassis at the same time. In some projections, that number is as high as 5 full chassis per cycle. This multi-cavity approach is crucial. It means that even if each casting cycle takes slightly longer due to the sheer volume of material involved, the output per cycle is dramatically higher. This is how Tesla can talk about production speeds measured in seconds per vehicle. It is not just about a bigger press, but about a fundamentally different production strategy built around scale and parallel output. The engineering challenges involved are immense. Handling such large volumes of molten aluminum requires extremely precise temperature control. The molds must be engineered to withstand enormous pressures without deforming. Cooling must be carefully managed to prevent defects, warping, or internal stresses. Even the foundations of the factory must be reinforced to handle the forces involved. These machines weigh millions of pounds and operate with tolerances measured in fractions of a millimeter. Achieving absolute precision at this scale is a monumental task, yet this is exactly the kind of challenge Tesla thrives on. The company has repeatedly shown a willingness to tackle problems others consider impractical by tightly integrating design, engineering, and manufacturing. Tesla can optimize vehicles specifically for casting rather than adapting casting to existing designs. This design for manufacturing approach is one of Tesla's greatest advantages. If successful, the 50,000-ton Super Giga Press could mark the beginning of the end for traditional automotive manufacturing methods. Legacy automakers are heavily invested in stamping plants, welding lines, and supply chains built around thousands of individual components. Transitioning to gigacasting at this scale would require enormous capital investment and a complete rethink of vehicle design. Many may simply be unable or unwilling to make that leap. For Tesla, however, the payoff could be enormous. Factories that function like money printing machines, churning out vehicles faster and cheaper than competitors can match. Cars that are lighter, stronger, and more affordable. Production lines that scale rapidly to meet global demand. This is not just about one machine. It is about redefining how cars are made in the 21st century. As the industry watches closely, one question looms large. Is this the secret weapon that allows Tesla to finally deliver electric cars affordable enough for every household? Or is it a risky bet that pushes the limits too far? If history is any guide, Tesla is willing to take that risk. And if the Super Giga Press performs as promised, the shockwaves will be felt across the entire automotive world for decades to come.